All right, guys. Today, so on your family tree, you should already have filled out quadrilateral and parallelograms. So now we're going to talk about the three different types of parallelograms. So the first one is a rectangle. So if a parallelogram has four right angles, then you would call it a rectangle. So if it has four right angles, so you're looking at stuff that looks like this. Right, four right angles. So that's the definition of rectangles, four right angles. One special property that we're going to be using is that the diagonals are congruent. So remember back here when it was a parallelogram, the diagonals bisected each other. Now we also know that the diagonals are congruent. And if you want to know what that is talking about, call this A, B, C, D. It's telling you that AC, this diagonal, is actually congruent to BD. I know my handwriting is pretty atrocious, but AC and BD are equal. Those diagonals are equal. We also know that since it's a parallelogram, we also know that it's bisected. So you actually know that all of these pieces are equal in a rectangle. So you know a lot. Rhombus. So rectangle had four right angles. A rhombus has four congruent sides, four equal sides, four congruent sides. So you're looking at this. All right, all the sides are equal. Two properties that are going to deal with a rhombus are that your diagonals are perpendicular. Remember, the symbol for perpendicular is an upside down T. Are perpendicular. So what does that mean? That means your diagonals cross at a right angle. So we're here. Here's a diagonal. Here's a diagonal. We know they're perpendicular. They're crossing at a right angle. Technically four right angles, but crossing at a right angle. And then the last one is your diagonals. This one's a little bit long. Diagonals bisect opposite angles. Diagonals bisect opposite angles. So again, what does that look like? This is a diagonal. We know that these two angles are equal. And we know that these two angles are equal. So those diagonals are bisecting. They're making two equal angles. And now if it's a rectangle and a rhombus, you would call it a square. This is four right angles and four congruent sides. It's got to have both. So the cool thing about this family tree is it does help you see the progression. If you've ever heard those square is always a rectangle is always a square, right? How do you classify? It's always from the bottom up. If you tell me it's a square, then you're telling me, yes, it has four congruent sides, so you can also call it a rhombus. Yes, it has four right angles, you can also call it a rectangle. Yes, opposite sides are parallel, it's a parallelogram. And yes, it has four sides, so it is a quadrilateral. So you actually kind of work your way backwards. If you tell me a rhombus, it's also a parallelogram and a quadrilateral. If you tell me it's a rectangle, it's also a parallelogram and a quadrilateral. So understand you always work backwards, which also means that all the characteristics that we wrote down on our family tree apply to a square. So thinking back to parallelogram, opposite angles were congruent. So in a square, opposite angles are congruent. They're just both 90. Consecutive angles are supplementary. In a square, 90 and 90 make 180. Consecutive angles add up to 180. Opposite sides are equal. In a square, all the sides are equal, so definitely yes, opposite sides are equal. So everything that was in parallelogram applies to a square. Everything that's in rectangle applies to a square. Everything that's in rhombus applies to a square. So if I ever ask you those questions, Is a square sometimes, always, or never a rectangle? A square is always a rectangle. It's always a parallelogram, but it doesn't work the other way. Is a parallelogram sometimes, always, or never a square? Well, sometimes, right? If the parallelogram had 4 right angles and 4 congruent sides, then yeah, it's a square. Okay, so understand you always work from the bottom up. So there's your family tree. Again, keep this, get this all filled in. The next couple days we're going to be filling in this side, and you'll turn this in complete, everything filled out on Friday. So this is the notes, just kind of showing you how to use the stuff that we've just been talking about. So let me zoom in here. All right, so this one says we're on rectangles. So understand opposite sides are still equal, opposite angles are, it's still a parallelogram. So here opposite sides are congruent because it's a parallelogram, or equal. The angles of a rectangle are all 90. They're all right angles. The diagonal of a rectangle, you're going to be using Pythagorean theorem because you do have, if you're talking about a diagonal here, you do have a right triangle. So a squared plus b squared is going to equal c squared. You might see some trig showing up in here. Opposite central angles are equal measure because they are blank. So remember, these were vertical angles. These are vertical. Vertical angles are always congruent. And that's not really a property of any nature. They're just pointing some stuff out to you. Diagonals are congruent. We talked about that. That was one of our properties, right? Diagonals are congruent. So they're congruent and they're also bisected, which again makes these pieces all equal. So if you have a rectangle, it's kind of nice, everything's equal. Alright, so let's try some examples. A, B, C, D is a rectangle with diagonals. Measure of angle 2 is 58. 58. Find the measure of angles 1, 3, and 4. So let's find the measure of angle 1, right? If this is a rectangle, you know this angle is 90. So we're going to do 90 minus 58. And we're going to get 32. So we know angle 1 is 32 degrees. And then remember, parallel lines, I cannot draw, I'm sorry. Cut by a transversal, alternate interior equal. So angle 3 is 32. And then angle 4 is 58, alternate interior angles. And that's all of them. Next one, in the diagram below, they tell you AC, so that's a diagonal. And they tell you DB, that's another diagonal. Again, the one property we had for diagonals was that in a rectangle, diagonals are equal. So 6x plus 2 equals 12x minus 10. We're going to subtract 6x from both sides. So we've got 2 equals 6x minus 10. We're going to add 10 to both sides. And we're going to divide both sides by 6. And they said find the value of x. We found the value of x. Next one says use the information to find the value of x. So here you have a right triangle. You have a right triangle, so we're going to set up a squared plus b squared equals c squared. Right? Your right angle, your c is always your hypotenuse. So we got 9 times 9, we got 12 times 12. We're going to add those up and get 225. And again, your last step is always take the square root. With Pythagorean theorem, your last step is always take that square root. So there's my hypotenuse. Think about it, draw a picture. So sometimes they just give you the words and no picture, and you have to draw it on your own. So we have a rectangle, A, B, C, D. A, B, C, D. And the diagonals intersect. Diagonals intersect at point E. So there's where they intersect. AE is 20. AE is 20. It's that piece. Which means this piece is 20, right? Remember, diagonals bisect. That's a parallelogram, right? Not even just a rectangle, it's a parallelogram. You know if this one is 40, right? 20 and 20 make 40, then BD should be 40. That's a property of a rectangle. Diagonals are congruent. BD is 40, AC is 40. So what do they have? BD is 2x plus 30. And we just said we know that should be 40, right? Because AC is 40. So equals 40. Subtract 30 from both sides. And divide both sides by 2. And you get x is 5. Alright, so we're going to move on from rectangles now. So rectangle, really you need to be aware of the right angles. And you need to be aware of the diagonals are congruent now. They don't not only bisect, but they're also congruent. Rhombus, opposite angles are congruent. Again, still a type of parallelogram. Opposite angles are congruent. Consecutive are supplementary. Right, 180. Now what makes it a rhombus? That definition, remember, all the sides are congruent. All the sides are congruent. So you see those tick marks, all the sides are the same length. Properties. The intersection of the diagonals of a rhombus form 90-degree angles, which means they are perpendicular. And if you think back to one of our properties, I forgot the R, in that family tree, diagonals perpendicular, diagonals cross at a right angle. They also bisect each other, so they are perpendicular bisectors. Let's try some problems here. PQ is 3x plus 8. QR is 2x plus 17. Again, we know it's a rhombus because we read, so we know all the sides are equal. So we're going to set those two sides equal. 3x plus 8 has to equal 2x plus 17. Subtract 2x from both sides. Subtract 8 from both sides, and you get x equals 9. Next one, what do they give us? SPQ. So they give us this whole thing was 8x minus 14. And then they tell you angle 1 is 3x plus 3, which means angle 2 is 3x plus 3. Remember, diagonals bisect the angles. So these should add up to equal 8x minus 14. So 3x plus 3 for angle 1 plus 3x plus 3 for angle 2 has to equal 8x minus 14. So we combine like terms, 6x plus 6. And we're going to subtract 6x from both sides. We're going to add 14 to both sides. And we get x equals 10. Now they did not ask for x, they asked for SPQ. So SPQ is 8 times 10 minus 14. So 80 minus 14, and we get 66 degrees. And there's your final answer. And then last but not least, diagonals of a rhombus have lengths of 12, so that means 6 and 6, and 16, that means 8 and 8. And we know diagonals are perpendicular, so we're working with a right triangle here. 8 squared plus 6 squared, squared equals c squared. So we've got 64 plus 36. We've got 100. So c equals 10. 10, 10, 10, 10. Our perimeter equals 40 centimeters. All right.